Welcome to this session on basics of Scratch programming. So let's try to have a quick recap of the context we are into. So what we know so far is that what is a computer program. So if you're able to recall our previous discussion, we said that computer had two parts. One was software, other one was hardware. So hardware is the physical part and software is a sort of virtual part. So software and program, these two terms are quite frequently used interchangeably. So when we say program in this course, that means that that's the kind of program which we are aiming for, or we want to build uh, a program to solve a particular computational task. So now the question comes that how can someone write a program? For that purpose, we need to have a programming language at hand. So we need to be fluent in at least one of the programming languages. So that will help us to write a program. So when we write a program, uh, that essentially means that we have written a solution for a computational problem. And using that program, we can solve a computational problem. So for example, a toy problem could be that we have been given two numbers and our task is to add those two numbers. So we need to write those instructions in the form of a program such that the computer can understand them and then get the things done as desired. So another thing which we talked about last time was that a program is a sequence of steps. So program is just like a recipe. So its analogy is that if we have to, let's say, make tea, we need to have recipe. And we start from the list of ingredients, which we'll need while executing that recipe. So that a list of or sequence of or collection of ingredients is called input. So those inputs like milk, water, tea, sugar, and all those things which you want to pour into the pan for making tea are the input or the inputs to that particular solution which we are about to try. Once we have the inputs, we have received the inputs, then we write down the sequence of steps in the form of a recipe so that someone can follow those sequence of steps and get the desired product designed or formulated out of it. So in the context of tea, we need to follow those sequence of steps which we usually do while making tea. And as a result of following or executing those steps in the desired sequence will give us tea. So tea is the output of that whole recipe execution process. So in our context, we'll be writing a program as a recipe, which means that the sequence of steps is very important. So we need to logically organize the sequence of steps or sequence of instructions for the computer. And that whole sequence and collection of instructions makes up a program. And once the program is ready to execute, that means that the recipe is now ready to be followed. So computer will follow your instructions written in the form of a program, and it will just get things done as you instructed. So computers themselves are dumb, right? So as a programmer, let's keep this thing in mind. Computers can't understand anything on their own. So whatever you have written in the program, that that individual instruction and its sequence is very important. Otherwise, the things might be messed up. So if you have written a correct program and computer follows the sequence of instructions, then eventually as the product, you'll be getting some output. So for that toy example of adding two numbers, you'll be getting sum of two numbers if your program was correct to add two numbers. So now let's start with Scratch. Scratch is a programming language primarily for kids. The major benefit of starting with Scratch is that it is a visual language, which means that we'll have a decent, fresh, visual, colorful interface, and we'll be just organizing certain instructions to get certain things done. So you have two options to work with Scratch. One is that you download it. The other option is that you can work with Scratch in the browser. Go to scratch.mit.edu. Primarily, this language was designed at MIT. So start with Scratch. So let me share my browser with you, and I'll be using the browser to start with Scratch. So perhaps I mistyped it, scratch.mit.edu. So this is the kind of interface where you will land. And then if you click on this create button, this is the button which will land us to the first project. So you can watch this tutorial on your own if you want. I'm closing it for a while. So I'll be uploading a similar kind of very basic starting tutorial about Scratch or LMS, and you can also see the terms being used in this platform. So on this screen, we have like 3 or 4 major parts. So on the left side, we have this whole palette of different instructions, different blocks, which can possibly be dragged onto this white part. So this white part is the stage, is primarily sorry, not stage, it is called script. Script is an alternate term for program. So in this, in our context, we'll be using this term program again and again. So we'll be setting up or designing our program over here in this white space. And on the right side, we have this sprite, which is this cartoon. It can be like moved around, but its default position is 0, 0. And by 0, 0 means that if you like treat this whole white space as a 2D space in the form of X and Y coordinates, so its location is the origin, which is X, where X is 0 and Y is 0. And if you look over here on the lower side, there are like these values of X and Y. So I can manually set it X is 0 and Y is 0, just to make sure that this sprite is exactly at the center of this stage. So this part where sprite is located, this is actually the output area where we can see the impact of executing our sequence of steps, which we'll be writing over here. But on the left-hand side, this is the entire toolkit. So these are all possible things which you can pick from and put them over here in the desired sequence. So putting the instructions in the desired sequence is the core part of this whole discussion. That is the completely and that is completely an intellectual exercise. By intellectual exercise, I mean that it totally depends on you, that how you think of a solution for a given problem. And the way you think of a solution, you'll be designing the sequence of instructions over here accordingly. So if you look over here on these colorful bullets on the left hand side, so these are different categories of the possible things which we can do with the sprite, or we can include them in our program. So if you go to control, like there are different things like which are very important, and we'll be using them like quite frequently in our different problems, like wait, repeat, forever, if, and so on. If you go into events, then there is something which is very fundamental, which you'll be using in almost all cases. That is called when this green flag is clicked. And then there is when space is pressed, and different kinds of events are there. We might not be covering all of them in our class, but you can try them on your own once you get comfortable with the starting exercises. So let me drag this when flag is clicked over here. So this is now here. So this when flag is clicked, we call it that when this event is triggered, that essentially is linked with this flag over here. So if you look over here, so there is a like this small tooltip with this flag that says go, which means that when I click on go, so then this sprite will be taking some actions. So as I have clicked at go, you can observe over here that the sprite did not do anything. The reason it did not do anything is that we did not add anything into our program. We don't have any sequence of instructions over here, so we don't have anything at hand which can possibly be located over here. So let's start with this like a little bit of fun part. So if you go over here in sound, so there is an option sound, please start sound meow. So meow is the sound okay, which is for the sprite. So now there is one instruction under this umbrella when flag is clicked. So if I click the flag, so let's try to figure out that can we hear anything or any action on the end of sprite. So if I click over here, so you might have observed that sound over here, or that the action has taken place. So let me try it once more for just for the sake of fun. Or interestingly, you can actually record your own voice over here. So if you don't like this voice of the cat, you can actually record your own voice and try it over here. So now in order to get rid of this instruction, if I don't need this instruction in my program, so then I can drop it back to this palette, or I can right click on that and delete this whole instruction. So there are many other things which are like there which you can try. So for example, in looks, there is something which is say hello. So let's say and this hello is now in a white text box, which means that I can change it. So let me try to write here, say, welcome to the world of programming. So if I write here, so if I now click on flag, so you can see this message over here on the sprite. So sprite is in a way saying, welcome to the world of programming. And we can similarly display different kinds of messages over here. Now there are like very interesting and useful blocks available in this palette. So for example, if you look on the first one that says, say hello for only 2 seconds, or so these white spaces mean that we can change them. So for example, we wanted to say hi for, let's say, 4 seconds. So now if I click on the flag, so you may see over here hi is there, but this hi disappears after 4 seconds. So this is not there forever, right? So the simple say was meant for displaying something, some message there for an unbound amount of time, but we can bound it with the seconds. But these are like very tiny and easy things. Simple output can possibly be generated in the form of sound or text on the sprite. So this right hand side is primarily our output area. This is the stage. We will be able to see all those things happening here on this side. So if you go to motion, there are some other possible things which we can get done. So for example, we can use this first block from the top. I drag it over here. So it says move 10 steps. So I maybe because this 10 is a like editable area. So I can change this 10 with something, let's say 50. So now if you observe the sprite closely, I'm clicking on the flag and sprite has jumped some steps towards right. If I click it once more, it jumps some more steps to the right. So from its current position, it is changing its X by 50. And that can be observed over here at this part of the stage, that X has become 100. Why it has become 100? Because we started from 0 and we clicked on the flag twice. And in each execution, it took 50 steps. So 50 plus 50 is 100, but we are not moving, we are not making any change in the vertical direction. So Y is still 0. So if I click it once more, it becomes 150 and sprite has moved further to the right. Or if I keep on clicking it once more, so it becomes 200, and then eventually at 250, it partially disappears. So now, like, there are two ways to bring it back. One is that I can drag it like this. I can drag it over here and bring it back, or I can just go over here in X and Y, and I can change X and Y to 0 and 0 so that it gets settled. And there is another way of getting the same thing done. So let me move away this move block for some time. And then there is something which is called go to XY. So if you look over here, so if I execute this command, it says that go to X00. So now if I click over here, it does not change position of the sprite because it is already at 00. But if I slightly change it, let's say I make it 50 and I make Y 100. So this sprite is supposed to move in this 2D space, in this two-dimensional space. Along x-axis, it has to take 50 steps, and along y-axis, it has to take 100 steps. So it should be somewhat moving in this diagonal direction. So let's give it a try. So if I click it over here, so it has moved that way, and you might have observed this physical movement, but you can also get it verified from these values of X and Y that they have become 50 and 100 this time. So this is another way of getting it move moved in multiple or in both of the directions, because the two space, so by multiple direction, we mean that we can at max deal with these two vertical and horizontal directions. So, or I can like make another thing which I can do is that I can make both of them 0 and 0 over here. And if I click it over, click on the flag, so the sprite will go back to its 0, 0 position. So let me keep this first instruction as it is. So I will say that move to the first to the origin to where x is 0 and y is 0. And then what we do is that we ask it to move, let's say 10 steps. Let me make it 50 steps. So it moves 50 steps. And then I go to the control part and I bring something interesting from here, and that is called wait. So after moving 50 step, I ask it to wait for 1 second, and then I ask it to move another 50 steps. So now if you look at the sequence of instructions, I essentially have 4 instructions in my program, 1, 2, 3, and 4. And the sequence is important because if the program is correct, the program will be executed, or the instructions will be followed in this particular sequence very strictly. So we ask it to move to the origin where x is 0 and y is 0. That is the first instruction. Then we ask it to move for 50 steps forward. So it jumps over here. And after 50 jumps, we ask it to wait for 1 second. Let me make it 2 seconds to make it like little more obvious in our visualization. And then we ask it to move another 50 steps. So now if I click on the flag, so it moved 50 steps, waited, and then it moved 50 steps again. Now, interestingly, what I want to do now is that I want to click on the flag again, and what will be the possible output which we can see on the stage? What will happen with the sprite this time if I click on the go button again? So pause the video over here, think yourself, and figure out that what should happen. So if you paused the video and thought of some answer, so you may compare your answer with the answer which I'm about to do, because if you look at this program again, the first instruction is go to x0, y0, which means that the sprite won't be moving forward. Instead, the first thing which will happen is that it will be reset to the origin. It will reset its position to the origin, so its x and y will become 0. So if I click on the flags, you can see that it has gone back to the first position, and then it started moving. So it is dragged back, and then it starts moving. Right? So to make it little more obvious that it really waits at the start. So what I do is that I keep the first instruction as it was. And then from the controls, I bring this wait over here. So we ask it that if the position has been reset, then wait for 2 seconds at the start. And then move 50 steps, and then wait another 2 seconds and move 50 steps. So now you can observe it over here. So it is at the origin, moved 50 steps, and moved another 50 steps. And if I re-click over here, so it always starts from that position and it keeps on moving 50 steps and 50 steps in the right direction. So this is a valid program which contains a few instructions, and the program is being executed in the same flow as written in these instructions. So let's try to expand this program now. So if I go to motion again, so we can ask it to make a turn. So let's say if we make this turn as something like 90. So let's see what happens, right? So when we say make turn, and so the sprite goes to return, moves 50 steps, moves another 50 steps, and then takes a turn. So if you look at its visualization, it has taken the turn, right? So the speed, because there was no wait, so speed of the processor is much faster than our speed. So actually these two steps were, the last two blue steps were executed in the sequence, but the speed was very fast. So we could not visually observe. If you want to observe it visually, you can always insert a weight, a block in between, and you can see it happening on the screen. So for example, if I bring a weight block from here, let's say it waits for 1 second, and then we can visually see that how this takes the turn. So it restarts. Oh, so the problem is that we did not change its direction. So now if you look over here, so it restarted, but its orientation was like already tilted 90 degree. So when we tilted it another 90, so it has become an inverted sprite. So let's do it once more. So it restarted, moved this direction, because now it's when we say move 50 steps, so it is taking like its orientation is its direction is dependent on its orientation. So let's do it once more for the sake of fun. And this time it has become this thing. So now if you observe over here, so now if I like do the same thing again, so it will start moving towards right, because now its orientation is matching uh, with the right direction. So it moves right, another right, and takes a tilt of 90 degree. So what we want now is that we want to like I go to this motion stuff again, and one like quick shortcut could be that I just disconnect this sequence of instructions, and I go to this turn thing and just want to reset its position. So I ask it that, because currently it's like it has moved at the angle of 90 degree in the clockwise direction. So we are now asking it to move in the at the 90 degree in the anti-clock wise direction. So it becomes this state sprite. So this command has now like made it a normal sprite. So we ask it to go to X and Y. So this time what we want to get, the kind of stuff which we want to get done is that we want it to start from the origin, move 100 steps towards right, take a turn, move 100 steps downwards, or might be, 100 steps. Then we ask it to take another 100 steps in the left direction, then 100 steps in the upward direction, which means that we want this sprite to keep on moving along 4 lines to make up a square. So it will be actually walking on the perimeter of the uh, of a square uh, of a square whose one side is 100 steps. So let's try to expand it. So this is what is doing it. So these lines are actually getting the first 1/4 of the task done, because it starts from the origin, moves 100 steps. So what we can do is that we can like we can do a similar kind of thing, that once it has taken the turn, we ask it to take a small step, a small pause over there, so that we can visually observe that it is really moving in the doing things in the desired direction. So we once it has taken the turn, we ask it to move this time maybe 100 steps altogether. And then we ask it to take another turn in the clockwise direction at the angle of 90. So now it is, after taking this turn, it is ready to move another 100 steps, which will take us to the left direction. So we ask it to move 100 steps in the left direction. And then we ask it to take another turn in the uh, clockwise direction at the angle of 90. And then what we do is that we ask it to move another 100 steps. So let's see what happens. So I think it has, let me reset its orientation. Something bad happened with its orientation here, probably. So its orientation is now pretty much fine. So we ask it to start from 0 and 0. It moves towards right, and then comes down. So something happened, right? So because we did not insert the weight in between, so we might have missed something. So it took the turn of 90. first, then another 90, another 90. So probably we should ask it to take the turn of another 90 when it reaches to the origin at the end. Okay. So now let's try to see it. So some certain things have happened, but we could not observe them like very closely because there was no wait in between. So let's try to insert small pauses in between. That what are the kind of things which are happening to make sure that things are really happening in the desired direction. Uh, okay, let's see. So it starts from the origin, moves right, moves right, moves down, moves left, moves up. So now if you look at the current position of this sprite, this is actually x0, y0, which you can verify from here. That means that it has gone back to its origin and it has actually traveled over a square practically 400 steps, like in total, like 100 steps in each direction. So now if you look at this whole sprite, this whole script, which is a program. So this contains many instructions. So in other words, this is a recipe for the sprite. So now sprite is like pretty much comfortable with following this recipe because this recipe is in its language, right? So we can get like certain more little bit more complex tasks done using the same number of tools which we've just learned: wait, move, turn, go to, and all those things. So you can take any shape and get this whole sprite move along the stage in that particular sequence of direction. So I'm about to trash this one because if I just like throw it back, so it's now again like ready for another possible program. So what we can do is that let's try to explore a few more things. So now there is another like interesting small thing which we need to understand. So if you recall your basic knowledge of mathematics, in algebra, there used to be two kinds of things in expressions. One was constant, other one was variable. So constant is something whose value is fixed, which means that you cannot change it. So for example, if I say 5, so 5 will always remain 5. 5 cannot change its value. But if I say your age, so age is something which is continuously changing, right? Or which is periodically changing. So age is a variable, right? Or if I say your current semester number, so that is again something which is a variable, which might be some semester number X at the moment, and next year it will be different, and so on. So there are certain things which can possibly change in the real world, and there are certain things which should not change. So all those things which can change are known as variables in mathematics, and same is the term which we use in programming. And variables are like one of the smallest possible data containers. Those are the places in computer's memory which we can create, and then we can use them for storing some temporary results. So if you look over here on this palette, on the left side, the second lowest category is variables. So we go into variables, and there are like options that we can create a variable. So on the top, there's a button which is called make a variable. So I click on this button and it takes me to this window where I can name a variable, right? So for example, I ask it to create a simple variable X. So the first variable which we are creating in our program is named as X. I write it as X and we click OK. So now if you look over here, so there are a couple of changes which you might be able to observe on the screen. One is that X has been listed over here in the list of variables. Additionally, X has been added onto the stage and it has been given a value, initial value 0, which means that X can be used. X is something which has been created in computer's memory. And in the programming courses, when we say computer's memory, that means that we are actually referring to the temporary memory, which is RAM, which is random access memory. So this data container has been created in computer's memory. Uh, and that we can use it for some intermediate temporary tasks. We can get certain things stored over here in X, or we can manipulate them. So for example, if you X has been like assigned 0. So if you look over here at the rest, at other possible blocks in the variables category. So one like small thing. So just for the sake of simplicity, what I'm about to do is that I'm deleting this pre-made variable, my variable, just to keep our life a little simpler. So let me drag this set X to 0. So the first instruction which we are doing over here is that when flag is clicked, this variable should become 0. But as you might have observed in our previous discussions, this 0 is white, which means this is the editable area. We can change its value. So let's say we make it set X to 5. So now if I click at the observe over here, right? X is 0 in the stage. But if I click at flag, this X should become 5. So as I click at flag, so X has become 5 over here in the memory. So one way is that we can just like keep an eye in the memory. This is a like snapshot of the memory, that what is the current value of X in the memory, that is 5. But you might be able to do little more interesting things. So for example, if you go in looks, you might be interested in saying that, say, hello. So hello is something which is the text, but if I go to variables, I can drag this X and replace hello with X. So which means that now this X has been dragged from the palette variable. So the sprite should be able to recognize this X as a variable in the memory. And when we click at flag, so it says 5, which means that it is now fetching the value from the memory stored in the variable X, and that thing is being displayed on the output screen, which is with the sprite that is saying 5. So it didn't see, observe, it did not say X, it is saying value of X. Why? Because there's a difference, and we should be like little careful about that thing. So if I just throw this X away, so if I just type X over here, so this is also X at the moment in say, but if I click at the flag, it says X, which means that it could not recognize this X which I typed as a variable. So this X which I'm typing is being treated as simple text, somewhat very similar to what hello was being uh, manipulated over here before X. So, but if I really want that the sprite should be able to fetch value of X from the memory, then I need to drag this variable X and replace this text X with that variable, so that if I click on flag, so it should be able to fetch the value from the memory, and it should be able to say 5 instead of just saying X. That's a common mistake which like starting programmers usually make. So they mix both of these kinds of X's. So try both of them, but you should be able to figure out the difference and their importance, that in what kind of context you'll be needing what kind of things. So what I'm going to do is that let me try to make it 1. And now if I click on the flag, it says X is 1. Now there are like a couple of more interesting things. So what I want is that I bring this set X to uh, over here. And this white area is something which I can manipulate. I can write something over here. So I go in the operators, and in the operators, there is something on the top, which is two boxes can be added together. So I plug in this green box of addition inside that white space. And what I want is that I go to the variables palette again. I drag X over here. Sorry, I wanted to place this X inside the first placeholder of green box. And what I want is that the second option should be 1 over here. And then I put it back in place of 0. Now let's try to understand this thing. So what should have been happening? So ideally what we are trying to do over here is that the kind of things which should be happening over here are that So like at the moment I'm focusing on this part, right? So there are two things which are happening. One is that X is there in the memory. So that has been given a value which is 1. So the sub part within this expression, this part says that X plus 1, which means this value 1 is fetched, 1 is added into it and becomes 2. And if you look at the whole line, this whole expression means this whole expression means that set X to X plus 1. So X plus 1 has become 2. So when we say set X to 2, so that means that this 2 has to travel back and it has to overwrite 1 and this X should become 2. So in the memory, we should be able to see X as 2 after executing this line. I hope it was clear, but if not clear, and we are getting it recorded, so you can just go back and rewatch this part of the video so that you are pretty much comfortable with this expression. We'll be using this expression again and again in our coming discussion. So we should be very much comfortable with the kind of stuff that we've done so far. Sorry. Okay. So let's move forward. So now let me try to execute and see what happens in the memory. So if I click on the flag, so there are two things which has happened. Sprite is still saying 1. Why is it saying 1? Because the instructions are being executed in the sequence. The first instruction was that X has to become 1. The second instruction is that X, which means it is saying 1. And after it said 1, we are doing this last instruction, which makes a change in X that says that add 1 into X and put it back in X, so X has become 2 in the memory. But as we did not ask the sprite to say it, so it did not say it. So what we can do is that we can go back and bring something from controls, bring a small wait over here, maybe of 2 seconds, and then ask the sprite to say X once more. But now this time when sprite will try to say X would have changed. So it should be able to pick the updated value of X. So let's focus on how sprite displays things. I'm clicking on the flag. So it says 1. And after 2 seconds, it says 2. So which means that it has learned to increment 1 into 1. So if we start X in our first step, we start with 100. So it starts with 100 and after a while it makes it 101. So it has incremented 1 into 1. But we can change the jump size. So let's say we make it 5. We start with 100. So it says 100 and then it says 105. Or using the same expression, we can actually do the reverse thing. So it starts with 100 and it makes it 95 because we are adding -5 into X. So you can play with this thing. So one small thing which I'm about to do now is that I am actually going to pick things from here. Let me right click on it and I say duplicate. So which means that another copy of this thing has been created. And let me do this thing once more. I add another duplicate. So what I do is that I put things here. Oh, something bad happened. So let me stop it. So I ask it to start with 1 over here. I ask it to increment 1 into 1 and then keep on incrementing 1 as we go forward in the program. And after every increment, we ask it to wait for 2 seconds so that we can see on the sprite side that how things are changing. So let's focus on the sprite and I'm going to click on the flag. It says 1. After 2 seconds, it says 2, then 3, then 4. So because we've written this whole thing 4 times, so it is counting 4 times. And if you write it 10 times, it will be able to count things from 1 to 10 or 100 or like 1,000, depending on the kind of stuff which you might have written over there. Right. So interestingly, there will be like some easy stuff in our coming session where we'll be able to use some other tools where it can like reduce our writing effort. But at the moment, we should be like just comfortable with this thing. So if you are like comfortable, pretty much comfortable with the kind of stuff you have seen so far in this session, that is good. If not, please watch this part again so that you become comfortable till this moment. And the last thing which is part of this session, which we'll be doing in a while, is actually dependent on the kind of stuff which you have been doing so far. So you should be comfortable with the stuff done so far, just to make sure that you are able to catch up things. So let me try to remove this whole thing. So let me drag it back and it goes away. So sprite is there, variable is there in our program, we can use it. So let's reset it to axis, let's say something over here, and we'll see that what do we mean by that. So we try to see another small thing. So one like critical thing which we need to understand is that all those things which we have seen so far are practically uh, being executed in the sequence. So step number 1, 2, 3, 4 of the recipe are being followed in the same spirit as they are written in the program or in the recipe. So now we are going to see a small new thing, and that is called if. So I bring in this block which is called if, and within this block there is this diamond type thing over here, which means that needs to be filled with something. And if we go to operators, there are different shapes of operators. So we have already used this plus operator, but this is an oval shape operator. So it cannot fit over here in this diamond shape. But if you look over here, there are some diamond shape operators, which means that we call them that they are the operations which are operators, which can help us to compare different things. So let's start with something over here on the bottom. That is that if something equals 50, then do this thing. So which means that we are actually now going to compare two things. One is left hand side, other one is right hand side of this equal thing. So if both of the things on the left and right hand sides are same or equal, then whatever we write over here should be done. Otherwise, it should not do anything. So for example, we go here and we say that we go in our variables. So let's try to drag this variable and put it over here. So if x is 50, we just want to say over here in if bool x is really 50. So if you look over here, our current value of x is being set to 0, right? Or some other number, let's say 5. Let me click on the flag. I clicked on the flag. Value of x has become 5 in the memory and sprite is not saying anything. Why is it not saying anything? Pause the video over here for a while, concentrate on the program and try to figure out that why are we not getting anything in the output. So the reason is that x is being set to 5. The next instruction is that x is being compared against 50. So this green diamond is called a condition, is a comparison between x and 50. So if both sides are same, then we say that this comparison or condition is true. And if they are not same, then the condition is false. So this say block will only be executed if the condition is true. Why will it only be executed if the condition is true? Because it has been embedded within the if block. So it is part of the block. It is not after if statement. So it's no more independent. So it is dependent on the truthfulness of this green part. If this green block is true, then that means that x and 5 are same, and it should say cool x is really 50. So now we have just seen that we clicked on flag and the sprite is not saying anything. So let's try to make it 50. So let's set x to 50 at the start and then see that if this green box and this condition works. So let's click on the flag. Now it says cool x is really 50. Why? Because in the memory x is 50. When we reach to this if block, 50 is being compared against 50. And this time left hand side and right hand side are equal. As they are equal, so it is now capable to say that say cool x is really 50. Right? There is a small thing. I'm just throwing it back. And let me bring a similar kind of if statement, but that's a slightly extended if statement. So that has two parts. So it has if diamond sign, which means we need to put that comparison thing over here. If that is true, then do this first blank, fill this blank, first blank part, write some instructions over here. So those instructions will only be followed if the if comparison is true. If this comparison condition is giving us the answer true, which means that that holds true, and it is matching or meeting the criteria, then it will be doing this thing. And within the same thing, there is something else which is known as else. That else means that do this part, second part, if the condition, if the given condition was not true. For example, if I try to bring the similar kind of thing once more, I write here if x is 50. So say we say, wow, x is 50. And in the else part, we write here some other message. Oh no, x is not 50. So let's try it here. So we need to fill this if condition with x. So we go to variables, drag x, put it over here. We click on the flag. It says, wow, x is 50. Why is it the output? Because in the memory, we are setting x as 50. We can see it here as well. When we reach at this green condition, so both left and right hand sides match. So the criteria is being met over here. Condition is true. So this green box is returning us the answer true. So we follow whatever is following then. So that says, wow, x is 50. And as a result of this whole thing, else part is being skipped over. Versus if we make the first thing something else like 51, now when we reach over here at if, 51 and 50 are not same, which means the condition is false. And in that case, this wow statement should be skipped and it should jump to else and display the output accordingly. And let's see it in the output. If I click on go, it says, oh no, x is not 50. Okay. Let's keep this structure as it is, and let's try to make a small change over here. Now this time I'm never going to compare. I'm not going to compare this x against 50. Instead, I'm replacing this x with something else. And that is that we go to operators once more. And there is an operator over here on the bottom side of this green palette that is called mod. So what we do is that we take x and we say that x mod something. So what is mod? So if you're able to recall your basic math, so mod is somewhat like this, right? So if I take 5, I divide it over, let's say 3. So 3 ones are 3, 2 is the remainder. So this 1 is called quotient, 2 is the remainder. So this mod operation actually gives us this 2, right? So we can divide x over any number, and whatever is the remainder of that division, that will be answered as x mod that number. So we are using mod over here for a very small mathematical problem, and that is that. So if you are able to recall some basic stuff, so what if I have to check x mod 2, so if I divide a number over 2, there are two possibilities about the remainder. The remainder will be either 0 or 1. Just think about this command, right? You should be comfortable with this command. If not, then do some practical manual exercise on paper that if you divide an integer over 2, what are the possible remainders you can get? So if I divide x over 2 and I put it over here in the first box, and if that answer is 0, what does that mean? What does that mean? So I hope you were able to figure it out. That means that the input is even number. So x is an even number. So even number is a number. If it is divided over 2, our remainder is 0, then it is even. If this green condition, the bigger green condition is false, what does that mean? That means that x mod 2 is not 0. So if it is not 0, that means that x is not divisible over 2. And what does that mean? That means that this whole thing is, this input is an odd number. Right, so if you look over here in this example, our default x being set to 51. So let's see it, click on go, what happens? So X is set to 51 as the first statement. We run the if condition. It says if X mod 2 equals 0. So X is 51. We divide 51 over 2. Divide it on your own on the page. Figure out the remainder. And the remainder will be 1. If the remainder is 1, 1 equals 1 is being checked. Is the condition true or false? Is 1 equal to 0? Answer is no. If answer is no, then the first block, then block will be skipped over and we'll jump into else part. So else says say odd number. So it says odd number. So if I go over here in 51 again and I write 52, so the program will be re-executed and 52 mod 2 is 0. So it should be able to say even number. And the good thing is that this program, this smart program, are having a few lines or few number of steps is a very good recipe, is a very good program to just determine whether the given input is an odd number or an even number. All right. So that's it for today. I hope you were able to capture this thing. So the benefit of recording is that you can always rewatch it in case of any confusion. I would strongly recommend to have a good grasp on these concepts which we've covered in this session before coming in the next session. Thank you very much. Have a good day.